So, solving one-step equations. How can we do that? Before we start solving equations, we need to establish a crucial idea. Let's start with basic numbers. Let's start with something like 3 times 4, and that we know that's equal to 12. We're going in this direction, so we multiply. How about going to the other direction, in the other direction, if we want to reverse this equality? To reverse it, we know that we need to say 12 divided by 4, and that's of course going to give us 3. So, what we need to remember from here is that these two mathematical operations, multiplication or division, are what we call inverse operations. So multiplication is the inverse operation of division, and division is also the inverse operation of multiplication. Same thing applies to addition subtraction. For example, 3 plus 4 equals 7. We can also reverse this statement by saying 7 minus 4 is also equals to 3. Right? So again, addition is the inverse operation of subtraction, and subtraction is the inverse operation of addition. Right? Now, this is a crucial idea that we need to keep in mind every time we talk about equations. Let's go ahead and take a first example about an equation. Let's start with something very simple. 5x or 5 times x equals to 3. I need you to remember that every time we're talking about an equation, there are two crucial sides, a left side and a right side. Think about them as a scale that has balance. So it's like you have a scale and they're balanced, they're equal to each other's. Alright? The left side has to be equal to the right side every single time. Anytime you add something to the left side or to the right side, or double something, you have to do the exact same thing to the left side. Anytime you remove something out from one of the sides, you have to remove exactly the same amount from the other side. Right? So, now these two crucial ideas, the idea of balance or equality or doing the same for every single side every single time, and the idea of inverse operations will help us to solve equations. Let's see how can we use these two to solve the following equations here. 5x equals 3. Well, we'll ask ourselves first, what does it mean to solve an equation? When I ask you to solve an equation, I need you to write what's the value of the missing number. Here, the unknown quantity or the variable is x. I just need you to write me the answer. X is equal to what? Do not tell me negative x is equal to something. Do not tell me 2/3 of an x equals to something. Don't tell me x plus something is equal to something. I just need you to write x alone equals to how much. Alright? So what you need to do is to isolate the x and get rid of anything else next to the x and put all of it to the other side. How can we do that? Of course, we cannot just take something from this side and put it on the other side and expect the scale to be balanced. That's not going to happen, right? So, in this question here, in example number 1, we need to get rid of the 5, obviously, because we need the x to be alone. We'll ask ourselves, what's the operation between 5 and x? It's multiplication. We go here. What's the opposite of multiplication? It's division. So we need to divide by the 5 to get rid of it. But now you're dividing this side by 5. You're reducing its value. So you have to do the exact same thing to the other side. Right? Once you do so, go down, start a new line, and write whatever left in each side of the equation. So on the first side, you have 5 divided by 5, and that's going to be equal to positive 1 only. So what you're left with on the left side is just the x. So you write x. Then you have the equal sign. Go down and write the equal sign. Now on the right side, what do you have? 3/5? 3/5. Do you have x alone on one side of the equation? Yes. Is the coefficient positive 1? Yes, that's it. You solved the equation. How would you know whether or not your answer is correct? You can check your answer. To check your answer, you go back to the original equation. The equation was 5 times x equals to 3. Now what you need to do is to do something called substitution. You will take the value of x, whatever you found out here, and replace it with the x in this equation. Right? So you're going to say, now x is not just a mysterious number, it is actually 3 over 5. And we know that it's a multiplication between them. So let's see if that's going to work. 3 over 5 times 5. And of course it's 5 over 1. Is this going to be equal to 3? Let's check that. Go down another line and say 5 times 3, that's 15. Of course, you multiply fractions, multiply across. 1 times 5, that's a 5. Is 15 divided by 5 equals to 3? Then your answer is correct. Alright? Okay. I'll give you a few moments. I'll write the second question and give you the chance to solve it. Question number 2 is x divided by 5 this time is equal to 3. I know that you can guess the answer, so I'm going to add some decimals on it and say, okay, it's 3.2. Alright? So now use the strategy to find out the x here. I'll give you a few seconds. If you feel free to pause the video if you want. Alright, following the same strategy. I need to isolate the variable. I need x to be alone on one side without anything else. So I really need to get rid of the 5 here. And I'll ask myself, what's the operation between x and 5? How can I break this bond? You can break it by doing the opposite operation. And that is multiplication in this case, because x is divided by 5. So you have to multiply by 5 to get rid of it. But this is what's going to happen. You're going to take the entire term here and times it by 5. And of course, this is the left side of the scale or the balance, okay? You have to do exactly the same to the right side. But be careful. You have to multiply everything on the right side with the 5. Now it's going to be just a number. Later on, when we take two steps equations, it might be more than one number here, right? So you have to multiply both parts by 5. What's going to happen next is that on this side you have 5 over 1 times x over 5. So you're going to end up with 5 divided by 5, which is just 1. And 1 times x is just x. Write your equal sign right there. And then just calculate this. 3.2 times 5. Right? Of course, you multiply decimals, you multiply normally, then add the decimal at the end of it. If you could do it this way, 3 times 5 is 15, plus 5 times 0.2, or 5 times 1/5. Of course, that's 1. So 1 plus 15, the answer is 16. Check your answer. You're going to say, okay, x divided by 5 is supposed to be equal to 3.2. So now I know that x is equal to 16. Let's try that. 16 divided by 5 is equal to 3.2. Let's write it as a mixed number to check that. We know that there are 2 5s in 16. So it's 3 5s in 16. That's going to be 1 on top. So 3 and 1/5. Is that going to be equal to 3.2? Of course, 1/5 is 0.2. So your answer is, again, correct. What about addition and subtraction? Let's take the following example. 3.2, let's make it negative. Negative 3.2 plus x equals 7.1. Now, a common mistake, a lot of the students will look at this equation and say, okay, because it's addition, now I need to get rid of the 3.2. I'm supposed to use the opposite operation, so I'll just gonna do subtraction from both sides. Now that's a mistake. Why? Because this positive sign is for the x. Alright? What you need to look at is the numbers sign. Alright? So we have a negative 3.2 here. To get rid of it, you're going to add the opposite of it. What's the opposite of negative 3.2. It's positive 3.2. Okay? Why we do that? Why we choose the opposite? Because any number you add it to its opposite, the answer is going to be always 0. And that's what we need. We need to cancel this number from this side of the equation, from the left side, and of course move it to the right side. So instead of subtracting, if you subtracted 3.2, you're going to end up with negative 6 over 4. You're not canceling this term. Okay, so be careful. It's always about the sign of the number you're trying to get rid of. This number is negative, so to get rid of that, you use the opposite sign, which is an addition sign, all right, or a positive sign. And of course, you have to do the same exact thing to the right side of the equation, and you're going to add 3.2. Rewrite your equation. You're going to have x alone on one side, isolated. X is equal to 10.3. Check your answer. Very quick. Rewrite the equation. Negative 3.2 plus x equals 7.1. And use substitution. Now we know that x value is 10.3. And we want to make sure that this is correct. So we're going to solve this statement here. 10.3 plus negative 3.2. Alright? Or another way, we could line it up as 10.3 minus 3.2. What's that going to be equal to? Did we get the same answer? So our answer is correct. Try to solve the following one. Number 4. If we have 50 equals to 3 minus x. Feel free to pause the video if you want to think about the question. Okay, so the x is on the right side and we need to get rid of the 3. This is not a negative 3. It's a positive 3. Alright, so to get rid of it, we need to add the opposite of it. What's the opposite of positive 3? It's a negative 3. So you have to do the same thing to both sides. Alright, you end up with 50 minus the 3, that's 47, equals to 3 minus 3, that's a 0. What are we left with? It's not x, it's a negative x. You have to be careful of this sign. It's negative x. Is this an answer? Can you just give me this as an answer for the equation? No. You need to get rid of the negative sign. But what is exactly the negative sign? The negative sign is just a negative 1. So you could divide both parts by a negative 1, or just multiply both parts by a negative 1. It doesn't matter. Because negative 1 divided by negative 1 is the same as negative 1 times negative 1, which is always going to give you a positive 1. So the sign now cancels off from this side. However, the sign of the left side switches to a negative 1. So the final answer is going to be x is equal to negative 47. Check your answer. Oh, this is a tricky one to check. Let's go ahead and try to check this answer. 50 equals to 3 minus x. We know that x, we decided that it's going to be equal to negative 47. When we substitute, we're going to make sure that this negative sign is going to be in between the parentheses. So the equation is going to be actually 50 equals 3 minus negative 47. And the double negative signs here makes a positive sign. So 50 positive is indeed equal to 3 plus 47, which is 50. So our answer is correct. And that's it for one-step equations. What you need to do now is do more exercises.